Okay, good morning, afternoon, or evening. How you guys doing today? Welcome back to Mr. Morrow's algebra class. Today we're going to be talking about 1-6, solving for a variable. When we're solving for a variable, sometimes you're gonna see this as called literal equations. Okay. Now you may be thinking, wait a second, we just learned how to solve for a variable. You taught us the single-step equations, you taught us two-step equations, and you taught us multi-step equations. We were solving for variables the whole time there. Yes, absolutely. But today, we're going to have equations and formulas that have many different variables. We're going to choose one particular variable, and we're going to solve for that one particular variable. This is a very easy section, but a lot of my students have problems with this because they don't realize that variables have the same properties as numbers, right? For what I mean by that, let's say I have x plus 5 equals 9. I know I subtract 5 to both sides, right? And I have my x. Well, if I have x plus a equals 9, and I want to solve for x, all I got to do is subtract a to both sides. So the properties of numbers and variables are equal. Whatever you can do to a number to get a variable alone, you can do to a different variable to get a particular variable alone. Okay, so let's first start talking about formulas. A formula is a mathematical formula is an equation that describes how two or more variables are related. When you evaluate, think about how we've evaluated before. When you evaluate a formula, you will substitute certain variables with given values and solve for the unknown variable. So remember what evaluating means. Okay, if I have, for example, 2x plus 3, and I say x equals 9, when you evaluate, you are plugging in that value of x into the expression. In this case, 18 plus 3 would be 21. Does that make sense? Okay, so a formula, again, is the interaction, basically, of different variables. Okay, and we're going to learn how to manipulate that today. For example, the number of gallons of gas that you put in your car is found by the formula C divided by P equals N, where capital C is the total cost, lowercase p is the price per gallon, and lowercase n is the number of gallons. How many gallons of gas can you buy for $55 if gas costs $3.98? Please, don't look at this as a difficult thing. Look at this for what it is. They gave me capital C over P equals N, where C is the total cost. Well, in this case, how many gallons of gas can you buy for $55? Won't that be the cost C? Okay. If gas, actually, yeah, total cost. Let's see. $3.98 is the price per gallon, so that's my little p. And what did they not give me? What did they not give me, guys? N. Very good. And what is N? N is the number of gallons. And aren't they looking for how many gallons? So that's my N. So what I like to do whenever I have word problems like this, especially involving formulas, I like to define what each part is. And now that I know what each part is, it's really simple. C, which is 55, over P, which is 398, equals N, which is the number of gallons. Does that make sense? Okay, so now in this point, all you got to do is actually do the math, right? So we got 398 into 55. Remember the decimal here at the end. 1, 2, 1, 2. All right. So how many times does 398 go into 398 go into 550? Yeah, one time. So that's 398. Drop down to 0. Borrow, that's 14. That's going to be 5. And you had to borrow from here as well. So that's 1. Okay. How many times does 398 go into 1520? 4. I think 4 is correct. 5 is going to be way too high. So 4, we got 2, 3, 36, and 3, 9, 3, 15. Okay. Oh, no, too much. Too much. So let's try 3. Yep, let's try 3. So that's 24, 9, and 2. Okay. So that's going to be 3, which is 1194. Let me erase this, and let me shrink. Oh, hold on. Sorry about that. Let me shrink this up. Come on. There we go. Okay. Let's continue here. We got 6 here. Borrow. That's going to be 11. That's a 2. That's a 4. So that's 3. Drop that down. 398 is going to go into 3260. How many times? I'd say about 8. Yeah, because that's close to 400. So let's do 8. That's 4, 6, 72, and 6 is 8, 7, 31, 84. Perfect. So basically 13.8 gallons. So N equals 13.8 gallons. Please remember that when you're dealing with formulas, you must label your answers. You have to tell the reader what it is you just found. If you just put 13.8, what does that mean? $13.8? 13.8 balloons? 13.8 cars? No, you got to tell me. In this case, it's 13.8 gallons. So identify what you're doing and plug in. All right, guys. So let's continue. Let's look at example 2. The formula S equals P minus 0.25P gives the sale price of an item which originally cost P dollars that was reduced by 25%. Think about it. 25% is 0.25. It was reduced, so I subtracted it. Okay? That's kind of like the second method that I taught you. This is 100% of the value. This is 25% of the value. When you subtract it, you get 75% of the total. So this is just in a fancier equation. So I want you to find the sale price of a pair of jeans that originally cost $50. Okay, well, S is the sale price, and P is the original cost. Okay, so what do they give us? Find the sale price. So we're looking for S, right? That's the sale price is my S. We're looking for that. And the pair of jeans originally cost $50. So what does my 50 represent here? The P, the original price. Does everyone see that, gentlemen? Okay, so find the sale price. That was weird. Okay, so find the sale price S equals 50. That's P minus 0.25 of 50. And now let's just do the math. So I got 50 minus 50 times 0.25. Does anyone know? You could do it out. Come on, guys. Okay, those were all wrong answers. Hold on. Let's do it the long way. You got 25. That's 0. That's 10. 12.5 is correct. Yes. Remember, guys, the skills that I taught you have to be constantly learned. Is that my computer making the noise? Okay, I think it's outside. Sorry about those people who are out there watching that and saying, what is that noise? 50 minus 12.5 is $38.50. And that is my sale price. You are done. Does that make sense, guys? Yes, sir. Wait, what? Add the P. I didn't add anything. I evaluated. P was 50. So what did I do? Where I saw P in my equation, I evaluated it. Where I saw P in my equation, I evaluated it. I plugged in the unknown value because they gave me the known value. Does that make sense, my brother? Yes, sir.
Would they ever
If they give you x equals x minus, no, yeah, you're going to have a lot of unknown variables. And if you, no, you won't have to make up the value for now, but sometimes you will when we're graphing equations later on. So yes, they will have that situation where you have different variables and you have to find them. In fact, we're going to learn that today. Okay? Let's do another one. In 2004, Ernst van Dijk won the wheelchair race of the Boston Marathon with a time of about 1.3 hours. The race was about 26.2 miles. What was his average speed using the formula D equals R times T, where D is distance, R is the rate or the speed in feet per second or miles per hour or kilometers per hour or meters per hour, feet per minute. Speed, R is rate or speed, and T is time. And it depends on the problem. Time could be in seconds or hours or days or months or years or minutes. Okay, it depends on the problem. So for this particular case, remember we have D equals RT. Let's see what they gave us and let's see what we're trying to find. They said that the marathon had a time of about 1.3 hours. So that's going to be my T. So I'm going to replace my T with 1.3 hours. That's my T. The race was about 26.2 miles. That's my D. That's my distance. So I'm going to go ahead and replace my D with 26.2. What do I not have? What am I looking for here? The rate. So that's just plain old R. Does that make sense here, gentlemen? Now once I've evaluated it, now I can go ahead and solve. How do I solve for R here? How do I get that bad boy all by itself? Yes, sir. That's exactly correct. Since R is being multiplied to 1.3, you're going to go ahead and divide 1.3 to both sides. So R will equal 1.3 on the outside, 26.2 on the inside, 1 to the right, 1 to the right. Bring that bad boy up. That goes in 2 times, which is 26. That's 0. You bring down the 2. 13 goes into 2. 0 times. You got a 2, bring that down. 13 goes into 20 one time. It goes into 73. No, probably now more than 3. It's going to go in 5 times, right? Because 5 is 65. Okay, and we can keep going. But we're going to go ahead and read directions. It says round your answer to the nearest tenths. So since we needed to round it to the nearest tenths, which is this place, we had to go to the hundredths so we could round. You with me? So what would the answer be here? Round it to the nearest tenths? 20.2. And what are the units here? Yeah, what's the rate here? Miles, because didn't I go miles, guys? Okay, per hour, because that is my rate. My time was in hours. How do I know that? Because they told you hours. How did you know it was miles? Because they told you it was miles. Does that make sense, gentlemen? Awesome. All right. Yes, sir. If you wanted to check your work, sir, go ahead and plug it back in. 20.2 times 1.3 should equal 26.2. Okay? Does that make sense, everybody? Okay. All right. Let us continue. Now, let's get to the fun part. When we are evaluating formulas, that's nice and easy. But this gets a little bit more complicated. It's still easy, but you got to really focus and pay attention here. When solving for a variable known as literal equations, you will be asked to solve for one particular variable which must be isolated. Remember the goal of any equation. They're asking you to solve for some variable. That means that they want that variable all by itself, isolated, okay? And we're going to do that using the equation skills we have learned thus far. It is very easy as long as you remember the techniques for solving multi-step equations. If you're not good at solving multi-step equations, this is going to be very difficult. It's just the way it goes. So please review those multi-step equations, please. In order to solve linear equations, you must first of all determine the variable you're solving for. That is the most important thing here. We're used to a lot of times solving for x or y. Well, in a lot of other equations, you have many different variables. W, P, T, R, Q, S, Z. You know, there could be any host of variables. So don't just focus in on x. Read the question, pay attention, and determine, okay, what variable do I need to get by itself? Once you've done that, use the same techniques for solving multi-step equations in order to isolate the desired variable. Your answer will be included, it will include numbers and or variables. You're going to have variables on both sides of the equation. That's what messes people up. Don't be afraid of it. Don't be scared. Just pay attention. Simple, simple. The formula for Fahrenheit temperature in terms of degrees Celsius is Fahrenheit equals 9/5 C plus 32, where F equals Fahrenheit and C equals Celsius. Okay? I want right now, guys, I want you to solve for Celsius. That's what I want to isolate. That's what I want to get all by itself. So let's check out how to do this. Don't worry about this F here. Don't stress out about that. People always stress out about that. Don't. Let's focus on the C. My friends, what kind of an equation is this? What's happening to the C here? Sir, it's being multiplied by 9/5 and 32 is being added to it. So in this particular case, this is a two-step equation, right? How do we undo a two-step equation first? You undo addition and subtraction. Very good. So what am I going to do here first to start getting the C alone? What am I going to do, guys? There you go. I'm going to subtract 32 to both sides. Now, F minus 32, are those like terms? No. So can we combine those together? No. So this is F minus 32 equals 9/5 C. Now, how do we get rid of a fraction that's being multiplied to a variable? Thank you, sir. You multiply by the reciprocal. Okay? By the reciprocal. So, this is going to be 5/9 times F minus 32. Do not distribute it. The 5's here cancel, the 9's cancel, equals C, and I am done. Done. Over. Bye-bye. Isn't C alone? You have just solved for C. You're done. All we did was use the skills as before, guys. The only difference, this F here could not be combined. It wasn't a number. Whoop-de-doo. So what? Same skills. Don't stress your lives. Now, for those of you who don't like or don't want to learn or for whatever reason are afraid of using the reciprocal, this is another method you can use. F equals 9/5 C plus 32. You're still going to subtract the 32, my friends. So you have F minus 32 equals 9/5 C. You could do this. How could I get rid of the 5 that's being divided? How do I cancel division, guys? Okay, so I can multiply 5 to both sides. So now I have 5 times F minus 32 equals 9C. How do I cancel out the 9? Divide by 9, because I cancel out multiplication with division. And I still will get exactly the same answer. However, be honest, isn't it easier just to do it in one step by multiplying the reciprocal? So that's why I do it, guys. It's not because I want you to do it my way. I just think that it's easier. But if you want to go step by step and get rid of the division by multiplying and then get rid of the multiplication by dividing, that's fine with me. Whatever works for you. Whatever works for you. Either way is gold. Yes, sir. Okay, what would be the purpose of distributing 5/9? So now you have 5/9 F minus, that's 160. It's not 37, guys. You're multiplying. It's distribution. Over 9 equals C. You could do it either or. Either way, isn't my C alone? Yes. So why would you want to complicate your life and distribute if you don't have to? Does that make sense to you, my man? It's a great question. I thank you for that. Awesome. Yes, sir. I never said you didn't have to solve it. That is not what I said at all. I never said that. The question was, why didn't you distribute the 5/9? I said because you don't have to. The goal of this was to solve for C. Did I solve for C here in the green equation that you see here? Is C by itself? I did it. Now, he was asking, can I distribute? Sure you can. That's why I put an or. So if you give it to me like this on the test, it's going to be correct. If you give it to me like this on the test, it's going to be correct. So I never said you don't solve. I said that once you have solved the equation, okay, and you have the variable you need all by itself, the other side does not have to be simplified. You don't have to distribute. Can you? Yes. Do you have to? No. Does that make sense, son? Does that make sense? Thank you. Any other questions before I move on, my brothers? All right, let's do this. Now, practice is the way. Practice, practice, practice. That's all this is. Okay, I've got P equals IRT, where T is what I want to solve for. Okay, the letter that it's in parentheses, that's what I want to solve for. So, what is the relationship between I, R, and T? How do you cancel multiplication? So what am I going to divide to both sides? I, R. Very good. Very good. So P over I, R equals T. Done, done, done. T is alone. That's it. Can I find a value for T using this? No, not right now. You would have to give me the value for P, I, and R. But I have solved this equation for T. Does that make sense, my brothers? All right, let's look at number 2. Area equals 2, or A equals 2 times L plus W. I want to solve for W. Okay. The temptation here, a lot of people want to subtract L, but you can't. And let me tell you why. See how this is in parentheses? These guys are trapped. These guys are trapped, and the only way for them to be released is to get rid of this 2. But what is the relationship between this 2 and this parentheses? They're being multiplied because they do not have a plus or minus sign in between. How do I cancel multiplication, my brothers? Division. Very good. So I'm going to divide 2 to both sides, giving me A over 2 equals L plus W. I want to get W alone. What is happening to W here? Yes, sir. L is being added to W. How do I get rid of a positive L? You subtract L to both sides. A over 2 minus L equals W. Ding dong, the witch is gone. Bye-bye. You're done. Does that make sense, my brothers? Yes, sir. I don't understand the question. He asked, does it matter what order you put it? I don't understand the question. What do you mean? Please. No, I want to know. What do you mean, the order?
Like, let's say you had positive instead of a negative, because it would be negative L plus A over 2.
Uh-huh.
Wouldn't work, but let's say that.
Yeah, you could write it as negative L plus A over 2. Sure. I don't like to do that. I like to start out with positive. But the answer to your question is yes, you could rearrange that if you wanted to. Just make sure you don't mess with the signs. L's negative here. So you want to rewrite it? Rewrite it. But L better still be negative. Does that answer your question, sir? Thank you, my brother. Excuse me. All right, let's look at number 3 here, gentlemen. Y equals 5x minus 6. Oh, and just by the way, for you internet people, I am saying gentlemen because I teach an all boys school. So ladies out there, I am sorry. I'm not trying to offend you. Okay, people. How about that? People, how do we solve for x here? What's happening to x? Yes, sir. It's being multiplied by 5 and 6 is being subtracted from that. So how do I undo a two-step equation, my man? That's right. You're going to undo addition and subtraction first, so you're going to add 6 to both sides. Y plus 6 equals 5x. Now, how do I solve for x? That's right. You cancel multiplication with division. Divide 5 to both sides. Y plus 6 over 5 equals x. Done. X has been solved for. Number 4. I want to solve for y this time. What's happening to the y here? What's going on here? Okay, it's being multiplied by a negative 3 and no, and 2x is being added to it. Remember, there is no such thing as subtraction. This is really read as 2x plus a negative 3y equals 8. Remember, guys, subtraction doesn't exist. You're just either adding positive or negative numbers. So, if I want to get that y alone, who do I start with? What do I do? Hey, there's not an x there. There's a 2x. What do I do with that? There you go. Thank you, my man. Subtract 2x to both sides. I got negative 3y equals. Can I combine these two together? No, because they're not like terms. So negative 2x plus 8. How do I solve for y here, gentlemen? Divide by negative 3. Absolutely. So y equals negative 2x plus 8 over negative 3. Now, hold on, please. Pay attention to what happens here. Please remember that this is getting divided to this and this. Okay? So what happens here? This is really y equals 2x over 3 minus 8/3. Because negative 2 divided by negative 3 is 2/3. You keep it positive, keep it as a fraction. 8 divided by negative 3, it's negative 8/3. Yes, sir, you had a question. There you go. Thank you. I'm glad I answered it. Thank you, my man. Yes, sir. Yes, sir. Okay, the question was, can you write it as 8 minus 2x over negative 3? Yes, but start getting into the habit of putting the x before the before the number. Yeah, start getting to that habit. Thank you, sir. All right, can we move on? All right, let's do this. Okay, I got x plus y over 3 equals 5. I want to get the x alone. So what am I going to do? Very good, son. You're going to multiply 3 over 1 to both sides. Excellent. That cancels. I got x plus y equals 5 times 3. I can combine those. That's 15. And now how do I get my x alone, my man? That's exactly right. You subtract y to both sides. X equals, you could go either way. You could go 15 minus y, or you could go x equals negative y plus 15. Doesn't really matter either way. What you got to make sure of, though, is that that y stays negative, regardless of how you write it. Yes, sir. How can they combine? I'm not trying to be sarcastic, but are those like terms? No. Guys, you cannot combine these. This is a huge mistake. People do that. That is wrong. I'm not trying to be mean, guys. That is wrong. If I have 2 apples and 5 oranges, I don't have 7 oranges, because they're not the same thing. That's a 3, yes, that I multiplied. Does that make sense, son? Thank you, sir. Awesome. Awesome question. Okay, next, number 6. I want to solve for b here. What's happening to the b here? What's being added to the b? mx. So how do I get rid of an addition? That's exactly right. So I'm going to subtract mx to both sides. Can I combine y minus mx? Can I combine that into one unit? No, because they're not like terms. So y minus mx equals b. Done. Does that make sense, gentlemen? Why would it be plus if I subtracted mx to both sides, sir? Again, I'm not mad. I'm not trying to be sarcastic, but we got to think about these questions. You guys are asking good questions, but think about what you're asking. That can't be a positive? No, it can't be. Because in order for me to get rid of a positive, I got to subtract, my man. Thank you very much. Excellent question. May I continue? Okay. Let's move on here. Oh. Okay, I'm going to have to speed it up here a little bit. Yes, sir. Sure. Do it, my man. What do I do? Yes, I want to get the y alone, so I'm going to subtract ax to both sides. Absolutely beautiful, son. What am I left with now? By equals negative ax plus c. Okay? Now you divide by b. Excellent, young man. Y equals negative ax plus c over b. Done. Excellent. Excellent. Okay, number 8. I want to solve for b here. Okay, let's think about this. Guys, is b free to go, or is b kind of trapped? B is trapped. What do I need to get rid of to untrap him? The half h, right? Let's make our lives a little bit easier. How do I get rid of that 2 in the denominator? Absolutely. So I'm going to multiply by the reciprocal of 2 over 1. Giving me 2a equals, the 2's cancel, h times b plus c. We're almost free. The b and the c are almost free. What do I need to do now to get that b and c free? Divide h to both sides. Excellent. So 2a over h equals b plus c. What do I do now? Let's come over here. 2a over h equals b plus c. Subtract c to both sides. So I'm going to have 2a over h minus c equals b. I have isolated the variable. I am done. Excellent job, son. Excellent job. Does that make sense? My friends, does that make sense? Excellent. Let's continue. V equals this volume. Volume equals length times width times height. I want to solve for length. What's the relationship between the length, the width, and the height here? The L, W, and H. They're being multiplied. How do I cancel multiplication? So what am I going to divide to both sides? Oh, yeah. WH. That's what I'm talking about. Boom, boom. V divided by WH equals L. Does that make sense? Awesome. How about for number 10? A equals 4 pi r squared. I want to solve for r squared. I want to get r squared alone. What is the relationship between pi, 4, and r squared? They're being multiplied. How do I cancel multiplication? Oh, yeah. So I'm going to divide by 4 pi to both sides. A over 4 pi equals r squared. Does that make sense? See, it's the same thing as solving regular equations, except you're going to have a bunch of different variables this time. Same skills, though. All right, last but not least, I got volume equals pi r squared h. I want to solve for h. What is the relationship between pi r squared and h, sir? How do you cancel multiplication? So what am I going to divide to both sides? Oh, yeah, pi r squared. That's what I like to see. Excellent. Excellent. So volume divided by pi r squared equals h. Done. Number 12. Who wants to tell me how to solve for x here? Come on, tell me what to do. Go for it.
You add the y to the other side.
You first add y to the other side. Yes, sir. What am I left with, my man? 7x equals... Thank you. Good catch. You almost said 14y. Good catch. This is y plus 14. They cannot be combined into one unit because they are different terms. They're not like terms. Now what, my man? Divide 7 to both sides. And remember, this 7 gets divided to this and to that. So this is y over 7 plus 2. Done. It makes sense. Awesome. Awesome. Okay. How about a equals x plus y over 2? This is a good one. I got to get rid of this 2 here. So I'm going to multiply by 2 to top and bottom. To both sides. Giving me 2a equals x plus y. I want to get y alone, so I subtract x to both sides. 2a minus x equals y. How about 14? R equals e over I. I want to solve for I. Pay attention to this one. Where is I right now? In the denominator. When I'm solving for a variable, don't I need that to be in the numerator? Do you remember, guys, that when we first started talking about equations, I said you want to solve for x over 1, right? Okay, so how do I get that I that's in the denominator in the numerator? Thank you. You multiply by the reciprocal. Multiply I to both sides. So I have IR equals E. But I want to solve for I. So what do I do now to get I alone? You divide by R. Excellent. So I equals E over R. Now, I do not have much time left, so I'm going to fly here. Catch up with me. If not, that's why we have a video. I want to solve for z, so I'm going to multiply by 6 over 1. Giving me 6x equals yz. I want to divide y to both sides because that's how I cancel multiplication. 6x over y equals z. Done. Here I want to solve for L. So I'm going to multiply L over 1 to both sides. So I have AL equals R over 2. You with me, guys?
Yes.
And I want to solve for L, so I'm going to divide by A. Now here, pay attention to this. I'm going to divide by A. This is L equals. Remember how to divide fractions. Stay, change, flip. So it's stay, change, flip. So L will equal R over 2A. Remember, this is the beauty of video. If you didn't catch that, you need to watch it again. Watch it tonight. Thank you very much. Have a great day, and God bless you.